Hey guys, so a student met me in Zoom meeting today and asked if I could maybe show this method one more time and make it a little clearer, and I came up with a way to show that turn on a lot of light bulbs in their mind and they understand it now. My previous examples that I had done in my other video, these circles were really close to it, and you're probably like, well, what's the point? It doesn't make much of a difference. So I'm just going to do a different example that those circles will end up being a lot further apart. So if we remember, there's a line segment that let's call it A to B, and we're going to say that this point is C, and we need to draw a parallel line that goes through C. That's what the question would say. Now, I picked a point that was pretty close to where like the perpendicular line here would intersect with AB. I picked a point that was pretty close for my examples. This time, I'm going to pick a point pretty far away to be my point D. Okay? So let's get this measured. All right, as you know, your first step is to put a point D on the line and then put your pin on it and put the pencil and line it up with C. And draw a circle. Okay. Second step is to keep that the same size, move it to where it intersects, and I believe they called that point E. So same size as this, you're just moving the pin over. And you're going to draw the circle. It should go through point D over here. If it doesn't, then you had to have moved this. Because as you notice, this circle's radius is E to D, and D's circle is D to E. So they're the same radius if you kept this the same size. The next step is to adjust the compass, and you're going to put it on point E and C. You're going to measure that size. But you're not drawing the circle there. You're going to lift it up. You're going to put the pin back on D, the first place you started, and you're going to draw the circle. And where circle 2 meets circle 3, right here, that is our point F. And you'll notice that point F and point C are exactly in line with each other. Oh, I better put my ruler a little below so that I draw a straight line. And it is parallel to AB. So line CF is parallel to AB. Now, I just want to compare these two examples I did. I actually have multiple on here. So this was the line. Here was a dot on that we were supposed to draw through. These circles were really, really, really close in size. Some of you were like, well, why didn't I just use this point up here? Or why didn't I use something else? And the thing is, these don't seem like much of a difference. But when you really zoom in and you look at it really closely, the difference between this point and this point, where circle 1 and 2 intersect and where 2 and 3 intersect, is a substantial difference. So the further out you draw your D point, the easier it is to see this. You don't want to get carried away, but don't just draw your D point right below. Measure it and have it to the side a little bit, and you're going to be able to see why this really works. I'd like to do one more example here. I have this line AB. I want to draw it going through C. Well, it's the same steps. Pick a point. Let's call it D on that line segment A to B. Get my compass set here. Okay. Draw a circle. Oh, I didn't have it set perfectly. I need to redo it. There we go. I've redrawn it going through there. And now I move my compass to this point E that we just created. That is AB and the first circle. And I'm going to draw a circle there. Good stuff. Then I'm going to readjust where point E is and point C is. I'm going to fix my compass. Ooh, my pencil came loose. Yep, there's the right size. And then I'm going to move it over to D. Sometimes if you poke the pin in just a little bit, you make sure you have that consistent spot. You don't want to put a big hole in it, but that's what you'll do. And here is F. So if we connect C and F, these lines will be parallel to each other. If I were to measure across here, we get the same measurement any two perpendicular points along this line, so the shortest distance across.